Welcome to This Explainer. Today, we're embarking on a tactical rescue mission specifically for you IT administrators out there. We're looking at exactly how to recover a locked-out device using entirely non-destructive methods. We're going to break down a highly frustrating scenario, you know the one, where standard recovery totally fails, and we literally have to get our hands dirty to extract the system intact. Let's get right into it.
So, ever been locked out of an endpoint by a ghost in the machine? Imagine the absolute frustration. A simple work account removal suddenly leaves your endpoint completely inaccessible. You're staring blankly at a login screen demanding a user password you simply don't have, and lingering ghostly Intune artifacts are trapping the device in a sort of management limbo. No working administrative credentials whatsoever. The device is basically a brick, but the data inside is absolutely critical.
Here's our mission briefing for today. First, we're decoding error 8180000A. Second, getting WinRE and system access. Third, purging stale MDM artifacts. Fourth, verifying a clean Entra re-enrollment. And finally, 5, running through the recovery workflow checklist.
All right, part 1. Decoding error 8018000A, the stale MDM trap. What we have here is a severe lifecycle mismatch. On the cloud side, the device state is showing Azure AD joined as yes, but those Intune actions, they're stuck on pending. Trying to re-enroll just triggers error 8018000A because, well, the device thinks it's already enrolled. Meanwhile, locally, you are completely locked out of the OS with 0 administrative credentials. The root cause is actually pretty simple. The work account was removed without a full deregistration. That causes a massive lifecycle mismatch between the local operating system and Microsoft Entra ID.
Moving on to Part 2, WinRE and System Access, Breaching the Perimeter.
Okay, to execute our WinRE commands, first, boot the machine directly into the Windows recovery environment and identify your correct OS volume. Now, before going any further, and I cannot stress this enough, always back up user data while offline, because we're about to manipulate system binaries. You absolutely need an offline copy of critical files on an external drive just in case things go sideways. Once your data is fully secured, we move to the breach itself. For this next step, we're using a classic, time-tested technique. We're going to temporarily replace the sticky keys binary, that's sethc.exe, to forge a backdoor. First, copy the original file to the root of your C drive to keep it safe. Then overwrite the sethc.exe file in the system32 folder with the command prompt executable. Now we have to pause here for a really crucial safety warning. As an IT admin, you already know the risks, but replacing system accessibility files is strictly a temporary measure. Leaving a system-level command prompt accessible right from the Windows login screen is a massive security vulnerability, so you must restore the original sethvec.exe file the moment administrative access is securely reestablished. Do not forget that step.
With the trap set, go ahead and reboot the machine to the normal login screen. Now, hit the Shift key exactly 5 times. Instead of sticky keys popping up, this triggers a system-level command prompt. Boom! From there, we forge a new local admin key. You'll execute net user recovery admin to add a new account with a password, and then use net local group administrators to inject that user directly into the local administrators group. Just like that, you've bypassed the login restrictions and restored full administrative control, all without having to reset the device.
Which brings us to Part 3. Purging stale MDM artifacts, the PowerShell purge.
Go ahead and log in with that brand new recovery admin account you just created. First things first, we need to validate the current interest state. You'll want to run these exact terminal commands. Start with dsred command /status to see exactly what the machine thinks its current Entra join state is. Then execute dsred command /leave to forcefully command the device to drop any partial, broken Entra ID associations. This essentially severs those broken ties to the cloud.
Next up, we need to clean up the local machine's memory of ever being managed. But before we deploy our PowerShell cleanup scripts, remember, editing the registry requires extreme caution and precision. Seriously, one wrong deletion here can completely destabilize the entire Windows operating system. So take your time and double-check your paths.
Starting off our PowerShell purge, we've got to stop the machine from trying to manage itself. We're going to target and unregister any scheduled tasks containing the Enterprise MGMT path. These are basically the automated ghost processes that Intune leaves behind.
By piping the get scheduled task command through a where object filter, we can isolate only those stale MDM tasks and silently unregister them. Next, we move right into the registry. We have to forcibly, yet silently, rip out those stale MDM artifacts causing our 81.18.020A roadblock. You'll want to look directly inside the hkey_local_machine software hive. Specifically, deleting the Microsoft/enrollments and Enterprise Resource Manager/tracked keys will completely wipe the local OS's memory of its previous Intune enrollment.
And finally, to finish up the purge, we have to handle the cryptography side of things. This specific PowerShell command searches the local machine certificate store and specifically removes any stale MDM certificates tied to MS-organization access. Once that certificate is gone, alongside those registry keys and scheduled tasks we just dealt with, the local MDM state is completely 100% cleared out.
All right, on to part 4, verifying clean Entra re-enrollment secure extraction.
Now, the absolute most crucial point here is verifying these exact final steps to confirm a fully clean re-enrollment with zero data loss. First, you'll rejoin the device to Microsoft Entra ID, then check your status to verify Azure AD joined now cleanly says yes. After that, hop over to your Intune portal to ensure the enrollment completed successfully and that any old duplicate device records have actually been removed. Finally, just confirm that your user-specific policies, like Windows Hello for Business, are applying correctly. If all of these check out, your extraction is a complete success. Let's wrap it up with Part 5, the Recovery Workflow Checklist. Quick reference.
Here is your high-level summary of the entire non-destructive recovery workflow, perfect for quick reference out in the field. Step 1. Get into WinRE and back up that user data. Step 2. Use the sticky keys bypass for system command access. Step 3. Disassociate the broken Entra state. Step 4. Run the deep PowerShell cleanup targeting the registry and certificates. And Step 5. Execute a clean re-enrollment.
And here is your ultimate cleanup checklist. This summarizes all the required safety actions and technical targets. Definitely keep this workflow handy. It highlights that absolutely critical safety step of reverting your CEF-HCE-XE binary right alongside the exact paths for your PowerShell purge. Having this quick reference on hand is going to save you hours of troubleshooting when you inevitably face error 8018000A out in the wild.
We solved the crisis today, but it really leaves us with a vital question to ponder about the safety nets in your own offboarding workflows. Removing a work account shouldn't guarantee a system lockout, yet it did exactly that here. So, do you maintain a fallback local admin account for your managed devices? How resilient is your current MDM offboarding process? Take these lessons, update your playbooks, and keep those endpoints running smoothly. Thanks for joining me on this explainer, and happy troubleshooting.